All right, we're going to discuss the three types of plate boundaries in this screencast. I'm on page 360. The different types of plate boundaries. What are the different types of plate boundaries? Well, deformation may occur throughout a tectonic plate. However, most of the deformation occurs at boundaries where tectonic plates meet. These plate boundaries may be on the ocean floor, around the edge of continents, or even within continents. There are three types of plate boundaries: convergent boundaries, divergent boundaries, and transform boundaries. The plates move in different ways relative to each other at each type of boundary. As a result, certain landforms are produced at each type of boundary. All right, boundary type number one are convergent boundaries. Converge means to come together. When tectonic plates move towards each other and collide, a convergent boundary forms. These collisions involve different types of plates. For example, an oceanic plate can collide with a continental plate. The denser oceanic plate sinks beneath the less dense continental plate. The process of one plate sinking below another is called subduction. One place subduction is occurring is where the Juan de Fuca plate and the North American plate meet. That is up sort of off the coast of the state of Washington, that area. A convergent boundary also occurs where two continental plates meet. So you've got plates coming together where one of the plates has oceanic crust and one of the plates has continental crust. You can have plates coming together where both of the plates are made of continental crust. In that case, the plates push up against each other. The resulting compression, remember, compression is a type of stress. The resulting compression causes rocks to buckle. This kind of convergent boundary occurs where the Indian plate meets the Eurasian plate. Where the Indian plate meets the Eurasian plate, we have rocks that buckled and formed the Himalaya Mountains. Okay. A convergent boundary also occurs where two oceanic plates meet. Subduction also occurs at this type of boundary. The denser oceanic plate sinks beneath the less dense oceanic plate. Okay? So we have convergent boundaries where plates come together. And we can talk about convergent boundaries between an oceanic plate and a continental plate. We can talk about a convergent boundary between two pieces of continental crust. We can talk about a convergent boundary between two pieces of oceanic crust. Okay, but they're all convergent boundaries because the plates are pushing together. All right, boundary type number two is something called divergent boundaries. When two tectonic plates move away from one another or diverge, a divergent boundary forms. Tension occurs as the plates move apart and the lithosphere thins. Thinning allows the asthenosphere to rise towards Earth's surface and melt. The melting produces magma, which moves to the Earth's surface where it cools and solidifies. This process forms new lithosphere at divergent boundaries. However, the lithosphere does not become bigger. Old lithosphere is being destroyed in subduction zones at convergent boundaries when one plate sinks beneath another and eventually melts. Okay? All right, so we have new lithosphere being formed at divergent boundaries. Old lithosphere being destroyed in subduction zones at convergent boundaries. We have a divergent boundary that exists between North America and the Eurasian plates. These plates are moving apart under the ocean. In fact, most divergent boundaries are under the ocean, but not all of them. For example, part of the boundary between the North American and Eurasian plate, part of that plate boundary runs through Iceland. So Iceland actually has a divergent boundary moving through it, and Iceland is sort of being slowly split over time. All right, transform boundaries are the third type of plate boundary. Two tectonic plates can move past one another in opposite directions and form a transform boundary. Movement is mostly horizontal. Shear stress commonly occurs at transform boundaries. The plates do not move smoothly. Instead, they slowly scrape against one another, sort of causing an energy buildup, and then all of a sudden they break loose. Okay? So they shift suddenly after enough energy has built up, and basically they get themselves unstuck. And these movements cause rocks to break or cause distortion of the rocks. The San Andreas Fault is a transform boundary. It's a well-known boundary in California. It's located between the North American Plate and the Pacific Plate. However, most transform boundaries are found on the ocean floor. Okay. There is part of California that actually sits on the Pacific Plate. It's just a little sliver down by sort of running from sort of San Francisco down through the rest of Southern California. So a little bit of California is actually sitting on the Pacific Plate, and the North American Plate and the Pacific Plate are sort of grinding past one another. So I'm going to go back to lesson 1 with this map. Okay, we're talking about this little bit of area right here. Just this little sliver of California sits on the Pacific Plate, and this is the North American Plate, and they are trying to slide past one another. That's a transform boundary. All right. So one thing I want to do with all 3 of these is go back and let's see where it talks about the type of stress that's associated with each boundary. At a transform boundary, we have shear stress. Okay. At a divergent boundary, we have tension. Okay. And at a convergent boundary, oh, it says it in here somewhere, we have compression. Compression, there it is. Okay. Okay. All right, and then it asks us to place arrows on each tectonic plate to indicate the direction in which these plates are moving. Well, this is a divergent boundary, so I know that the plates are moving away from one another. So this plate is headed this way, this plate is headed that way, moving away. Down here, this is a transform boundary, so it may be that this one is moving this way, and this one is moving in the opposite direction.